Today here we will discuss about some MCQ on differential equation or the MCQs on differential equation of second order. As you know that in this year in COVID situation, MacOut will going to take the semester in online mode and also in MCQ pattern. So here I will just show you the basic of the second order differential equation and some related MCQ which is a great chance to ask you this type of question in your exam. And here you will just know that how to find the solution in a very short method, in a very short time. So here first of all we have to consider a second order differential equation. That is, if we consider a second order differential equation, that is d2y dx2 plus p dy dx plus qy is equal to 0. This is a second order differential equation and its degree is 1. So you can say this is a second order linear differential equation, and where p and q may be a constant or maybe a function of x. So now here the question is that how can we solve it? And here remind that when the right side of the second order differential equation is equal to 0, then we can say that this is a homogeneous differential equation. This is a homogeneous differential equation, and if the right side is not equal to 0, then we can say that is non-homogeneous differential equation. So now how can we solve this equation? To solve this equation, we have to find the trial solution. So here we take y is equal to a e to the power mx be the trial solution. And now if we find dy dx and d2y dx2, then what we get? m a e to the power mx and d2y dx2 m square a e to the power mx. Now if we put the value of d2y dx2 and dy dx in this equation, we will get one equation. That equation is known as auxiliary equation, which is we can write it like m square plus pm plus q is equal to 0. And now the solution of this differential equation is depend on the root of this equation, and here we will get the solution by using the Sridharacharya formula. And if we apply here the Sridharacharya formula, we get m is equal to minus p plus minus root over p square minus 4q by 2. And as we know that here this is a second quadratic equation, and here we get two roots, and then we now the nature of the roots depend on the this discriminant, and on the nature of the discriminant we will formulate the solution. So first of all we take the case that is when roots are real and unequal. That means here p square minus 4q greater than 0. In that case the roots are real and unequal. That means we get two roots m1 and m2, and the solution is of the form y is equal to c1 e to the power m1x plus c2 e to the power m2x, where this c1 and c2 are arbitrary constants. Now if we take the roots are real and equal, in that case that means the p square minus 4q is equal to 0, and here that is m is equal to, we take m1 is equal to m2. So the solution will be of the form y is equal to c1 plus c2x into e to the power mx. So as c1 c2 are also arbitrary constant. And last, and there are two more cases here. That's when roots are complex conjugate. That means p square minus 4q is less than 0 and also p is not equal to 0. That means the roots are of the form alpha plus minus I beta. In that case the solution is of the form y is equal to e to the power alpha x c1 cos beta x plus c2 sin beta x, and here also c1 c2 are arbitrary constant. And now at last condition is that the roots are purely imaginary. That means roots are of the form plus minus I beta, and here also we purely imaginary, and this will be purely imaginary when p is not equal to when p is equal to 0. In that case we can say the solution is y is equal to c1 cos beta x plus c2 sin beta x. So from here they can ask some MCQ also from here. So you have to just learn, you have to just note it that how can you find the solutions, because sometimes they want to know the conditions that when the roots are real and unequal, then what is the form of the solution. When roots are real and equal, then what is the solution. If roots are complex conjugate, then what is the type of solution, and when roots are purely imaginary, then what is the type of solution. So you have to remind that. So now I am just going to discuss about some MCQs on the second order differential equation. So now let us check some problems from here. So now I will just show you the first question. That is here, the question is that we have to find the auxiliary equation of the differential equation d square minus 4d plus 4y is equal to sine 2x. First of all, here the right side is not equal to 0, so this is a non-homogeneous second order differential equation. So please mind it that this equation is the non-homogeneous differential equation. Non-homogeneous differential equation. But now here the question is that we have to find the auxiliary equation. D square minus 4d plus 4y is equal to sine 2x. That means we can write it in this way, that d2y dx2 minus 4dy dx plus 4y is equal to sine x, where d2 stands for d2 dx2, d stands for d dx. Okay, so now from here we have to find the auxiliary equation. That means we have to find that y is equal to a e to the power mx be the trial solution. Now just find the dy dx and d2y dx2. We get this, and if we put in this equation, we will get the auxiliary equation is m square minus 4m plus 4 is equal to 0. And so from here we can say that the option B is correct. This question also asked in the question as a mark 1. Now I will show you another question, that is solution of the differential equation is d2y dx2 minus 5dy dx plus 6y is equal to 0 is. So here 4 options are given, that is c1 e to the power 2x plus c2 e to the power minus 3x plus B. Option B is y equal to c1 e to the power 2x plus c2 e to the power 3x. Option C, y is equal to c1 e to the power minus 2x plus c2 e to the power minus 3x. And option D, c1 e to the power minus 2x plus c2 e to the power 3x. So this is the equation, d2y dx2 minus 5dy dx plus 6y is equal to 0. Right hand side is equal to 0. So this is a homogeneous equation. So now here we have to find the auxiliary equation. How can we find the auxiliary equation? That is d2y dx2 minus 5dy dx plus 6y is equal to 0. So here you have to also put y is equal to a e to the power mx. Similarly, as this, you have to find dy dx and d2y dx2, and if you put, you will get the auxiliary solution is m square minus 5m plus 6 is equal to 0. This is a very simple middle term factor. So if you find the roots, then m, you get m is equal to 2 and 3. So now here, see here that roots are real and distinct. So here we have to find that y is equal to, the solution will be the format plus c1 e to the power m1x plus c2 e to the power m2x. And here as you take m1 and m2, so here we can say that y is equal to c1 e to the power 2x plus c2 e to the power 3x. Here m1, we take m1 is equal to 2 and m2 is equal to 3. And here also you can say that the option B is correct. So I hope you understand, and this is also a question number 1. So now I will just show you another one problem, that is the question number 3. So this is a very good question here. That is, it is given that y double dash plus 2y dash plus y is equal to 0, and also given that y of 0 is equal to 0 and y of 1 is equal to 0. Then what is the value of y of 0.5? See here, so first of all we have to solve this equation. That means first we have to find the auxiliary equation. So from here you can say that the auxiliary equation is m square plus 2m plus 1 is equal to 0. So from here we can get the roots are minus 1 and minus 1. That means roots are real and equal. That means the solution is of the form y is equal to c1 plus c2x into e to the power mx. And here m is equal to minus 1. So the solution is y is equal to c1 plus c2x into e to the power minus x. And now we have to find some points, some condition are given here. So here y of 0 is equal to 0 means at x is equal to 0, y is equal to 0. That means now if we put x is equal to 0, so we will get c1 plus c2 into 0 into e to the power minus 0 is equal to 0. And if we find, then we get the value of c1 is 0. Similarly, y of 1 is equal to 0 imply that when x is equal to 1, y is equal to 0. So now if we put here already we find that c1 is equal to 0, and if we put x is equal to 1 here, we get c2 e to the power minus 1 is equal to 0. So c2 is equal to 0. So now here we can say that the solution is y is equal to 0, and now also we can say y of 0.5 is also 0. So here option A is correct. Now I am going to a little bit different problem here. That is the complete equation, the complete solution of the ordinary differential equation d2i dx2 plus p dy dx plus qy is equal to 0 is y is equal to c1 e to the power minus x plus c2 e to the power minus 3x. Then we have to find the value of p and q, the value of p and q. So how can we find the value of p and q? So how can we find the value of p and q? This is quite a good question. See here, the solution is of the form y is equal to c1 e to the power minus x plus c2 e to the power minus 3x. That means the roots are real and distinct. So in that case, we can say the solution is of the form like this: m plus 1 into m plus 3 is equal to 0. Or if we simplify, we will get m square plus 4m plus 3 is equal to 0. M square plus 4m plus, and this is the auxiliary equation now. And if we consider the auxiliary equation with the main equation, this is of the form 3 is equal to 0. And now if we compare it with this, then we can say that p is equal to 4 and q is equal to 3. So here option C is correct. So I hope you understand. So now I am going to the last one more problem in this video. That is the solution of the differential equation d2y dt2 plus 2dy dt plus y is equal to 0 with the condition y0 is equal to 0 and y dash 0 is equal to 1 is, there are 4 options are given. So first of all we have to find, see here, in place of t, in place of x, here we put t. So here we will take the auxiliary solution as y is equal to a e to the power mt. Sorry, the trial solution. So the auxiliary equation, this will be m square plus 2m plus 1. So m is equal to minus 1 minus 1. So roots are real and equal. So we get y is equal to c1 plus c2t into e to the power minus t. So now here also given that y0 is equal to y dash 0 is equal to 1. That means first of all when x is equal to 0, then y is equal to 1. That means if we when t is equal to 0, when t is equal to 0, then y is equal to 1. So if we put t is equal to 0, we get c1 y0 is equal to 1. That means c1 is equal to 1. And y dash 0 is equal to 1, or y dash 0 is equal to 1. So first of all, if we find the derivative, that is y dash is equal to, we will get minus c1 plus c2t into e to the power minus t plus c2 e to the power minus t. And if we put here t is equal to 0, so we get minus 1 plus c2 is equal to 1 and c2 is equal to 2. So if we put the value of c1 and c2 here, so we get y is equal to 1 plus 2t e to the power minus t, and the solution answer will be also B. So I hope you understand. And see here that when some boundary conditions, that is these conditions like this one and the previous problem, these are known as the boundary condition. And when the boundary conditions are given, you have to find the value of arbitrary constants. Okay, so I hope you understand. So thank you very much.